We're going to take a look at operations with complex numbers. And just as a fun little refresher, complex numbers are in the form of A plus BI, right? A plus BI, where you have number plus number times I. And now when it comes to operations with complex numbers, what we're going to look at today is addition, subtraction, sort of subtraction, I guess, and multiplication. We'll get to division for another time. So we'll get to it, but we're going to save him for a little bit later on. Now, complex numbers in the form of A plus BI. I need you to know, so note, we treat I like a variable, except we know that I squared equals -1, I to the third is -I to the fourth is 1, and so on, right? So we can always switch these. We don't ever want to leave I to any power other than 1. Right? We know that I equals I, but these, we saw this in our pattern video, but this is where we're going to run into some extra steps where, if I ended up, I times I equals I squared in something, I want to switch it to a -1. And so we're going to treat I just like a variable, exactly like a variable. So like combine like terms, just like we normally would and everything like that, except whenever we end up with an I squared, I to the third, I to the fourth, or whatever, we have to switch it, okay? All right, here's what I mean by that. Let's do a quick example of what I mean by that. So for addition and subtraction, addition and subtraction is kind of relative, but let's take a look. It's addition, subtraction. All right, no, we just want to combine like terms. So we're going to combine like terms. So what I mean by that is, if I had something like, 4 plus I plus, I don't know, 7 minus 6I, right? Okay, just making it up. If I had something like this, we're just going to combine our like terms, right? 4 and 7 are the real parts, right? So there's just a 4 and a 7 to get 11. And then I and -6I, so +1I and a -6I would leave me with -5I, right? And that's it. That's as far as you have to take it. But whenever it comes to like multiplication, so let's do for multiplication. We would follow the patterns of distribution and FOIL, okay? And we'll do a couple of those examples here in just a second. So let's just take a look at a few examples that we're going to see with our homework. Or how do I do this? Okay. So some examples that we're going to get from the homework. Here, this is just simple addition and subtraction, or addition in this instance. Combine our like terms, right? -1 and -4. This is a -5. -8I and -1I gives us a -9I. And that's it. As far as I have to take that. 3I plus I, right? These are two complex numbers. The first one, 0 plus 3I. The second complex number is 0 plus I, right? But here I'm just combining my like terms. 3I and I is a grand total of 4I, right? So that's it. Nothing more I have to do with this guy. These problems are pretty simple. And now here we get to multiplication. So here I have 5I times a -I. 5I times -I. And we're going to treat this just like you would if it was x. If I told you 5x times -x, you'd end up doing pretty well with it. But here we get 5I times -I. So 5 and -1, that's a -5. I times I is I squared. So here I get -5I squared. But this is where things are different than a variable. right? If I have I squared, I have to turn it into a negative 1. So instead of negative 5I squared being my final answer, negative 5 times negative 1. And that ultimately is just 5. All right, so 5I times negative I turns into just 5. All right, let's take a look at another multiplication example here. Here I have 7I times 3I times negative 8 minus 6I. There are 3 complex numbers here. You can handle this in a bunch of different ways, and I suggest maybe trying a different way than I do it so that you can get to the same answer and show yourself. What I'm going to do here, though, is I'm going to distribute 3I here and here, and then I'm going to multiply it with the 7I. So 7I stays the same, but now I'm going to distribute here. So 3I times a negative 8, well, 3I times negative 8 is going to be a negative 24I. 3I times a negative 6I is a negative 18I squared. And now remember, with that I squared, I got to switch it to a negative 1. Right? So I have to switch I squared to a negative 1. I get 7I times a negative 24I minus 18 times negative 1. And a negative 18 times negative 1 is a positive 18. So here I get 7I times negative 24I plus 18. And now I'm going to distribute the 7I. And nobody in their right mind knows what 7 times 24 is off the top of their head. I got a calculator. Woohoo! So 7 times 24 is 168. Okay, so 7 times negative, so a negative 168. I times I is I squared. And 7 times 18 is 126. So I get plus 126 and then I. I squared is not just I squared. I can't leave a squared. So I squared turns into a negative 1. So I get negative 168 times negative 1, 126I. A negative 168 and a negative 1, that all turns into a positive 168 plus 126I. And that would be my final answer. All right, let's take a look at a couple of others. Ooh, here we go. I like this. I like it. 2 minus 4I times negative 6 plus 4I. Here, we're just going to do regular FOIL. All right, so 2 times negative 6. 2 times negative 6 is negative 12. A 2 times a positive 4I is a positive 8I. A negative 4I and a negative 6 is a positive 24I. A negative 4I and a positive 4I is a negative 16I squared. All right, now there's 2 things that we have to clean up here. There's 2 things that we need to clean up. One, we have to combine like terms. So get a little CLT. The second thing that we need to do is switch the I squared to negative 1. So I get negative 12, and 8 plus 24I is a positive 32I, and then negative 16 times a negative 1. All right, so those are 2 things that we had to do. I combined 8I and 24I to get 32I, and I switched I squared to negative 1. And now I get negative 12 plus 32I, and negative 16 and a negative 1 is a positive 16. And my last step here is to combine my like terms one more time. Positive 16 and a negative 12 is a positive 4 plus 32I. And that is my final answer. So when we FOIL, there's an extra step than what we're used to, right? We're used to combining these like terms and we're done. However, when I have that I squared is really -1. So I got to take that extra little step there to churn it and then combine my like terms one more time. Okay, let's take a look at 1 minus 7i squared. Remember, you cannot distribute an exponent over a binomial. I know you really want to, and no matter how many times I've said this, oh, the hundreds of times that I've said this in class, you still somehow just don't know. And that's okay. We're going to keep saying it until I die, probably. 1 minus 7i squared really says 1 minus 7i times 1 minus 7i. Now that we can FOIL. 1 times 1 is 1. 1 times a negative 7i is minus 7i. Negative 7i times 1 is a negative 7i. Negative 7i times a negative 7i is a positive 49i squared. Now remember our two steps here, right? At this point, we want to combine like terms and switch I squared to -1. So combining my like terms, -7i is a negative 14i. The second thing I want to do is get that I squared, so plus 49 times -1. I switched I squared to -1. Now I'm just going to multiply, so positive 49 times positive 49 times a -1 is a negative 49. Negative 49 and a positive 1 gives me a negative 48 minus 14i. And that is as far as I can take it. All right, let's take a look at one more. 6i to the third, right? 6i to the third means 6i times 6i times 6i. And nobody knows what 6 to the third is, so oh, if you said 216 at home, you were right. So here we have 216 I times I times I to the third. Now remember, I to the third from our patterns. Of course, I can't find that note anymore. Yeah, I to the third is -I. Okay, so here, 216 I to the third is 216 times -I. And that simplifies to -216i.